Well, okay, here we are. I hope that you all are doing okay. I would rather be going over this with you in person in the classroom, and I know you'd rather be there in the classroom, right? Yeah. Trig functions, or trig ratios. A lot of students like this time of the year because we get to trig ratios and they find it to be fairly simple or fairly easy for them to understand and be able to do. If you look on your calculator, whether you have a black one like this, a yellow one like this, or one of the older yellow ones, they will all have these three buttons right here that say sine, cosine, tangent. They're abbreviated, but that's what they mean. And we've never used them before, but now we're going to start using them. But what do they mean? These are all ratios, comparing one side of a triangle to another side of the same triangle. And it's a right triangle to begin with. Sine is spelled S-I-N-E, or S-I-N for short. And that comes from taking the opposite side of the right triangle and dividing it by the hypotenuse of the triangle. And we'll get into what that means in just a moment. Cosine similarly uses these sides of a triangle, but cosine uses the adjacent side divided by the hypotenuse. And then tangent. Have you ever gone off on a tangent? I'm sure you have. Tangent is abbreviated TAN, and it's the opposite side being divided by the adjacent side. Ratios. And there's an acronym that is used to help us remember these ratios. It's called SO, CA, TOA. This summer I'm going to go to Camp SOCATOA and SOCAMATOAs. Okay. And what that stands for, it's a way to help us remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Just ratios, fractions. Unless the instructions say, you will always leave your answer in fraction form, but there's some exercises you're going to do where it tells you to reduce it to the nearest thousandth or 10,000th. Only then will you leave it as a decimal. So what does this mean, opposite, adjacent, hypotenuse? All right, let's just start out with an ordinary looking right triangle. Everything you'll be working with to start with is a right triangle. Here's the 90-degree angle. It's got the little box in it, the 90-degree angle. If you draw an arrow through the 90-degree angle, it will always point to the longest side of the triangle. It is responsible for making that side. It's the largest angle, so it makes the largest side, and the largest side is called the hypotenuse. And no matter which way you turn this triangle, it doesn't change which side of that triangle is the hypotenuse. The longest side is the hypotenuse. Now the other two sides, for example, the one here on bottom, sometimes it's going to be called the adjacent, sometimes it will be called the opposite. How will you know? Well, it depends on whether you're asked to work with this angle here on the bottom or this angle here on the top. If you're asked to work with this angle here on the bottom, then the side that touches this angle is the adjacent. It takes the hypotenuse and the adjacent to make the angle you're working with. So this side is the adjacent, and that makes this side the opposite. This is the most difficult part about working with trig ratios. is figuring out which sides are which, and really it's not that difficult, but it is one thing that you will have to make yourself do to know which side of the triangle is called what. If you can do that, the rest of this is just a walk in the park. Let's look at the same triangle again. Perfect. How do I do that? All right, if I go right across from the 90-degree angle, that is always the hypotenuse. This time, I'm going to work with the angle up here. All right, the hypotenuse is coming together with this side over here. That makes this side the adjacent, which means that the third side where nothing is written is the opposite. Sounds simple enough. Here's the way that you will see it in your work. You will have a triangle, a right triangle. It may not stand up like the other two that I've already drawn. It may be laying down like this. And there might be letters at each of the vertices. And then there could be measures on each side. And then the instruction will just be sine of A, or they might even put the A in parentheses. What is the sine of A? First, go find angle A. Here it is. Mark it somehow so you'll know here's the angle that I'm using. Next, go around all three sides of the triangle and write down the names of each side. I just use an abbreviation. I use H for hypotenuse, A for adjacent, O for opposite. So looking at this, 13 is the biggest number. That's the hypotenuse. The hypotenuse comes together with this side to make that angle, so this side is the adjacent, which means the one that's left is the opposite. The opposite is right across from the angle that you're working with. So sine of angle A. Here's angle A. Sine of A equals. Right, sine is opposite over hypotenuse, and that equals 10 over 13. If the fraction can't reduce, then you're done. 10 divided by 13 does not reduce. I'm done. That's it. Well, let's look at some of your work. Here we go. Tangent of Z. Here's Z. If this is Z, the angle that I'm working with, and that means here's the hypotenuse because it's the longest side. Here's the adjacent because the hypotenuse and the adjacent make the angle you're working with, and here's the opposite. So the tangent of Z, tangent is opposite over adjacent. Opposite is 21. Adjacent is 28. And when I type that in the calculator, 21 divided by 28, math, enter, enter, 3 over 4. The answer is 3 over 4. Sounds simple enough. Let's try another one. Sine of angle C. Well, here's C, so I mark it. Now I go around and I label each side. Here's the longest side, hypotenuse. Here's the side that connects to the hypotenuse. It's the adjacent. The other side, the lonely one, is opposite. Now you can also draw an arrow through the angle you're working with and it will point to the opposite side. If you can make yourself figure out how to always find the hypotenuse and then either the adjacent or the opposite, just one of them, then the one that's left is going to be the one that you were unsure of. Okay, so here we go. The sine of angle C. Sine is opposite over hypotenuse. Opposite is 28. Hypotenuse is 35. I type that in my calculator, math, enter, and it tells me the answer is 4 over 5. Bada boom, bada bing. Number 5, working with angle A. Here's angle A. 34 is the longest side, so that's the hypotenuse. The side across from A is the opposite. That makes this the adjacent. See how I knew how to find the opposite side? I knew how to find the hypotenuse, and that meant the one that was left had to be the adjacent. Cosine. The cosine of A. Cosine is adjacent over hypotenuse. 30 over 34. 15 over 17. Not bad, huh? This is the way that your work should look. I strongly encourage you to write it out the way that I did right here. This helps you remember what it is that you're looking for. This helps you keep your numbers in the correct order. And then it's just a matter of going and finding those numbers and replacing them, checking with your calculator to see if they reduce. Okay, on the back, it's just more of the same. You're given measures for all 3 sides of each triangle. You did it exactly the way that you did on the front side, only this time when you write your answer out, you will write it as a decimal rounded to the nearest 10,000. That's 4 numbers after the decimal. For example, let's do number 15. The tangent of angle C. Well, here's C. Here's the hypotenuse. Here's the opposite because it's all the way over here across from my angle. And here's the adjacent. Okay, the tangent of C equals opposite over adjacent equals 12 over 35 equals. Now on the calculator, I just do 12 divided by 35, enter. I have to round this off to where that 8 is right there. So I look at the one just before the 8, it's a 5, which makes that a 9. 3429. 0.3429. And that's it. Uh-oh. Now we don't have any triangles. And the instructions want to know, what is the sine of 48 degrees? Well, that's even easier, but it requires you to set your calculator up first. This is degrees, so you need to push the mode button, and you see right here where it says radian degree. You need to go down and highlight degree, and then push enter, and then push second mode to exit. Now you'll begin using these 3 buttons right here. Sine, 48, enter. Round it off to the nearest 10,000th, 7431. Almost like a zip code, 0.7431 done. done. Then I'll mark these two out. I think you can do this. If you feel like pulling your hair out, if something isn't making any sense, please give me a call, send me a message, send me an email. You can call me at 1-903-818-1565. This is the number for the cell phone that I keep in the classroom. I have it with me. Call me, send me a message, whatever. Only make it appropriate. Don't get mean, because it's not like I can't find out who you are. It's just let me help you if I can. You can call me or send me a message this way. You can send me an email at Ector, if I could spell, Ectormath at gmail.com, or Mackey at ectorisd.net. And one thing that I will ask you to do is be sure and turn your calculator off when you're through using it for the day, especially the older ones, the big yellow ones. If you have one of those, the batteries don't stay charged very long at all in those calculators, and I have no way of getting more batteries to you. So be sure and turn it off each time after you're done using it by pushing second and then the on button. That turns it off. Okay, I hope you do well. Please try. Send me your work that you get done. We're going to get through this and everything's going to be okay.